In today's lesson, we're going to learn our next differentiation rule called the product rule. The product rule is used to find the derivative when we have two functions multiplied together. So in this particular case, we have the function f of x being multiplied by g of x, and the pattern to find the derivative is as follows. Y prime equals, that's the first function, multiplied by the derivative of the second function, plus the second function times the derivative of the first. Let's take a look at a specific example. So here we have our first function, which we'll call a, and our second function, which we'll call b. We want to take the derivative, and these two things are being multiplied together. So to take the derivative, the rule says I take my first function, 2x cubed plus 5, and I multiply it by the derivative of the second function, which is 6x minus 1. Then I add to it my second function, which is 3x squared minus x, times the derivative of the first, which is 6x squared. Now, I am done calculus right there, and many calculus textbooks will allow you to stop there, okay? But simplifying just reinforces some of our algebra skills. So let's simplify this by multiplying together. So I get 12x cubed minus 2x cubed. Whoops, that's not correct. Let's try that again. And we are going to get 12x to the fourth minus 2x cubed plus 30x minus 5. And then I'm going to distribute my 6x squared to get 18x to the fourth minus 6x cubed. Now if I collect like terms, 12x to the fourth, 18x to the fourth is 30x to the fourth. So I'm done with those. Negative 2x cubed minus 6x cubed gives me negative 8x cubed. I'm done with those. Plus 30x, take away 5, and that would be my derivative. All right, let's look at another example. In our next example, we're asked to differentiate the following. Well, again, I have a radical, and we should know by now, before I can take the derivative with the radical, I need to change it to a fractional exponent. So now, here's my first function, here's my second function. To find the derivative, again, I would use the product rule. And the product rule says it is the first function, well in this case the first function is x to the 1/2 times the derivative of the second function, which is negative 3, plus the second function, which is 2 minus negative 3x, times the derivative of the first, which is negative 2x to the minus 1/2. Again, I'm done calculus right here. Now it's a matter of simplifying. So if I simplify this, negative 3 times x to the 1/2 is negative 3x to the 1/2. Now I'm going to distribute this onto these two terms. And if I do that, I'm going to get a half times 2 is 1, and x to the negative 1/2 times, there's no variable with the 2, it's just going to become x to the negative 1/2. And 1/2 times negative 3 is negative 3/2, and that's really x to the first times x to the negative 1/2. I use my laws of exponents, and I add them. 1 plus negative 1/2 is going to be positive 1/2. Now to finish this up, I'm just going to look at my like terms. So I have a like term here and a like term here. But in order for me to add those, I'm going to need a common denominator. So I need to look at the common denominator of this and this, which obviously is, the denominator would be 2. So y prime is going to be negative 6 over 2 x to the 1/2 plus x to the minus 1/2 minus 3 over 2 x to the 1/2. And now if I gather like terms, I'm going to have negative 6 over 2 minus 3 over 2 is negative 9 over 2 x to the 1/2 plus x to the negative 1/2, and that is my derivative. Okay, in the next example, we're asked to find the equation of a tangent line. Okay, and they want us to find this equation at this point. Remember from previous lessons, to find the equation of a tangent line, we need slope and we need point. Well, we already have our point. It's right here. It's 1 and 5. Okay, the last thing I need to do is I need to find the slope. So to find the slope, I have to take the derivative. Well, if I look at my function, it's a function times another function. So I have to use the product rule. So it's the first function times the derivative of the second plus the second function times the derivative of the first. It's supposed to be an x. And again, we are done the math, the calculus right there. Okay, so at this point, I want to find the slope when x is 1. Now, there's no need to simplify your derivative at this stage. We can just plug a 1 in, and why is it 1? Because 1 is the x-coordinate of my point. So this is going to be 3 times 1 squared plus 2 times 6 times 1 squared plus 2 times 1 cubed minus 1 times 6 times 1. Again, that's kind of messy here. This pen is hard to write with on my screen, but just bear with me. There we go. So up here, I'm going to have 3 plus 2 is 5. 6 times 1 squared is 6. 2 minus 1 is 1 times 6, so my slope works out to be 36. So now I know my slope. I have my point, which was given as a 1 and 5. So once I know my slope and my point, I can find the equation by using my point-slope equation. And if you recall, we'll do it in red here. Y minus y1 is m. X subtract x1. So in place of y1, I put my y-coordinate of my point. x1, I put the x-coordinate. And in place of m, I put the slope. So this is going to be y minus 5 is equal to, my slope in this case is 36. X subtract 1. And depending on what form they want me to write this in, I'm going to go y subtract 5 is equal to 36x minus 36. And if I add 5 to the other side, I'm going to get y equals 36x. Now this pen is really going goofy. So it's going to be 36. And if I add 5 to negative 36, it becomes negative 31. So my final equation is 36x minus 31. All right, let's take a look at the last example here. And in this last example, if we can zoom in a bit, it shows that we are given two functions, f and g. F is the thicker graph on this graph, and g is the thinner of the two graphs, and we're asked to find the derivative of capital F. And if we take a look, capital F is the product of function f and function g. So in order for us to work this out, okay, the first thing we need to do is we need to take the derivative, the general derivative. So right now I have capital F of x is given as f of x times g of x. So the derivative of capital F using the product rule is going to be my first function times the derivative of the second function plus the second function times the derivative of the first. So there's my general product rule. Now in 21, they want us to find the derivative when x is equal to 2. So all I'm going to do is I'm going to plug 2 in place of x. So I have f of 2, let's get a darker color here. F of 2, or f prime of 2, is little f2 times g prime of 2 times, or plus g of 2 times f prime of 2. Now the key thing is we need to know the difference between what does g of 2 mean and what does g prime of 2 mean. And remember, we talked about this a while back. G of 2 would just be the y-coordinate when x is 2 on function g, and g prime is the slope of the tangent line on function g when x is 2. So let's fill in the chart as best we can. So at f of 2, if we take a look here, f of 2, I go to where x is 2, the y-coordinate of the thick graph is 1. So f of 2 has a value of 1, and I'm multiplying that by the derivative, which is the slope of the tangent line on the thin graph at 2. Well, if I calculate rise over run, I'm going down 1 over 1. My slope at 2 on graph G is -1. I'm adding to that g of 2, which is the y-coordinate when x is 2 on graph G, which is also -1, plus, or times, sorry, the derivative of graph f at 2, and if I calculate the slope of the tangent line here, I'm going over 1 and up 3, that slope is 3. So if I work this out, 1 times -1 is -1, plus -1 times 3 is -3. So therefore, the derivative of capital F when x is 2 is equal to -4. So questions 22, 23, 24 are very similar. You just have to use a different x value. So remember, this means the y-coordinate when x is 2, prime means the slope when x is 2. That concludes this lesson. So there's your assignment. Again, you can turn to the web page to find the answer key to that assignment, and good luck.